All right, we're looking at answers to review for test 2. Number 1, we need to use the limit process to find the derivative of the given function, which means we we need the limit as h approaches 0 of f of x plus h minus f of x over h. So that means I need to plug in x plus h where x is, so that's how we get this one, and then minus f of x, which is that, and it's all over h. It's always easiest to pull that h out front and make it 1 over h. Then I got a common denominator with what's left. So x plus 1 needed to come over here, and x plus h plus 1 needed to come over here. So that's why x plus 1's here, x plus h plus 1 is there. I have the minus here. When I distribute the negative, the x's cancel, the 1's cancel, and then h becomes negative, as you see there. H's cancel, end up giving me this. Again, remember, as soon as you cancel out h, then we need to plug 0 in for h, which is what I did here. So it's negative 1 over x plus 1 and x plus 1, which means I get negative 1 over x plus 1 squared. All right, we're looking at a graph on 2 through 4 to figure out where we're not differentiable. So that means we're looking for continuity issues, and we're looking for vertical tangent lines and cusp. So on number 2, we have a cusp. If we have a cusp, then that means we're not differentiable because the limit of the derivative does not exist. Make sure you put the derivative function in here. A lot of you on the quiz just put the limit and then put d and e. You didn't tell me what we were taking the limit of, so make sure you do that. On number 3, we have a continuity issue, so that means we're not differentiable because we're not continuous. Number 4, we've got a vertical tangent line right here, and when we have a vertical tangent line, then that means our reasoning is my derivative is undefined. 5, we did in class. Remember, in class, the first thing we did was rewrite it as 1/3 x cubed plus 1/2 x squared plus x. Pretty easy after that. Bring the 3 down, which cancels with the 1/3, changes into an x squared. Bring the 2 down, cancels with the 1/2, changes into x, and the derivative of x is 1. On 6, we are doing the quotient rule because I have a variable in the numerator and the denominator. Quotient rule is bottom times the derivative of the top. So derivative of sine is cosine. Make sure the inside stays the same, and then times the derivative of the inside. Then minus the top times the derivative of the bottom. Remember, on e, you're going to rewrite it, and then you're going to multiply by the derivative of the exponent. So the derivative of 3x is 3, and then we put that all over the bottom squared. Remember, when you're doing product or quotient rule with e, you should always be able to factor something out. I've got 2e to the 3x and 2e to the 3x, so I factor that out. Leaves me with pi and cosine here, and it leaves me with 3 and sine there. Then I can reduce one of these with one of these, and I end up with my final answer. On 7, rewrite the square root as a half, then do chain rule. So I bring the half down, inside stays the same, new exponent is negative 1/2. Then I do the derivative of tangent, which is secant squared, inside stays the same, and then I do the derivative of 5x, which gives me 5. Move the tangent to the bottom, and that leaves me with 5 and secant squared on the top, and 2 and the square root of tangent on the bottom. 8, super easy. Derivative of 1 is 0. Derivative of x is 1. Derivative of cosine is negative sign, so the double negative makes it a positive sign. Number 9, I think we did number 9 in class. Notice I do not have an exponent, I do not have a variable in the numerator, so that means we want to rewrite it and move it up, which is what I did here. Then we're doing chain rule, so negative 1/2 times 3 is negative 3/2. New exponent is negative 3/2, and then the derivative of natural log is 1 over the inside of the natural log. So I get 1 over x. The negative 3 stays on the top, the 2 and the x, and the natural log go to the bottom. Number 10, variable on the top, variable on the bottom, quotient rule. So we have the bottom, derivative of the top, minus the top, derivative of the bottom over the bottom squared. I had a negative cosecant squared here and a negative cosecant squared there, so I factored it out. That left me with 1 plus cotangent and minus cotangent. The cotangents canceled, and the only thing left in that parenthesis was a 1. Multiply those together, it gives me a negative cosecant squared over my bottom squared. 11 we did in class as well. We got a variable on the top, variable on the bottom. So we got to do quotient rule, bottom times the derivative of the top, minus the top, derivative of the bottom. over the bottom squared. Distribute here gives me this. Distribute there gives me that. The 6x's cancel. 4 and -9 gives me -5. My answer is D. Okay, which of the following values is the graph of f continuous but not differentiable? So continuous but not differentiable. Okay, so I'm just going to go through each of these and we'll talk about each of these. So number 2, we are not continuous right there. I have a limit and I have a function value. They don't match, so I'm not continuous. Number 3, I am continuous at number 3, but we have a cusp there, so that means we're not differentiable. So we are continuous, but not differentiable. So that's why that's our answer. Number 4, I'm not continuous because the limits don't match. And number 5, I am continuous and I am differentiable. Remember, I am differentiable because we're smooth there. We don't have a cusp. All right, 13, we need the product rule here. So we change that square root to a 1/2. So first, derivative of the second. So the 1/2 comes down, inside stays the same. New exponent is -1/2. Derivative of the inside is 2. Plus the second times derivative of the first. I move the square root down to the bottom here, and then I get a common denominator. So square root times square root gives me 2x minus 3. X and 2x gives me 3x minus 3. We like A. 14, f of x equals the square root of x squared minus 4. G of x equals 3x minus 2. We want the derivative of f of g of x. So first thing I need to do is put f of g of x together. And I did something different on this one than what we ended up doing in class. On this one, instead of doing like a double chain, I went ahead and multiplied this out. And I got 9x squared minus 12x plus 4. And then we had the minus 4 that was already in there. So those 4's cancel. And the only thing left inside is 9x squared minus 12x. And then I rewrote it with a 1/2. Now we do a chain rule. So 1/2, inside stays the same, new exponent, derivative of the inside. So the derivative of 9x squared is 18x. Derivative of -12x is -12. I move that back to the bottom. The 2 is down there as well. And then 18x minus 12 is in the numerator. Then we plug in 3, and we end up with 7 over the square root of 5 when we reduce it. All right, 15. Which of the following is an equation of the line tangent to the graph of f of x equals x cubed plus x squared at the point where f prime of x equals 1? Again, whenever you hear tangent line or line tangent, you should be thinking slope, which comes from the derivative, and you should be thinking we need a point as well. So this right here is telling me the derivative needs to equal 1, so that means I need to find the derivative. So I need to find the derivative of this, which gives me 3x squared plus 2x. Since the derivative needs to equal 1, I set 1 equal to the derivative and I solve. So I move the 1 over there, I factor, and I get 2 values for my x values. Okay, so I need to write an equation of a line with these two things. Remember in class I told you always choose the easier number first to see if you get an answer that matches. So I know my x value is -1. I know my slope is 1, so I need my y value. Remember, to get y values, it'll always go back to the original. So if I plug -1 in there, I end up getting -1 plus 1, which gives me 0. So that means my y value is 0. We already said my slope was 1 because that's what this tells me. Whatever the derivative equals is going to be my slope. So that's 1. And I plug in -1 for my x value, clean that up, matches A. If that didn't match, then you'd have to do the same thing with 1/3 and figure out what that is. 16, use the table to find the values of the derivative at the given x value. So I've got a composite function here. So that means we need to do chain rule. Derivative of the outside, inside stays the same. Derivative of the inside. I plug in 6, so 6 goes there, 6 goes there. G of 6, so here's 6, there's G, so G of 6 is 6. So I took G of 6 out, I put 6 in its place. G prime of 6, here's 6, there's G prime, so that's why I put 3 in there. Now I need F prime of 6. So there's 6, there's F prime, so I put a 4 in there. 4 times 3 gives me 12. 17, variable in the numerator, variable in the denominator. I need to do quotient rule. So bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. We're plugging in 4, so we plug 4 in everywhere. When you do that, you get a 1, you get a 7, you get a 0, you get a 1/2, you get a 1. Clean that up, you end up with 7 as your solution. All right, 18. At what point on the graph of y equals 1/2 x squared is the tangent line parallel to the line 2x minus 4y equals 3? So again, tangent line right there. So that means we need a point and we need a slope. We get slope from the derivative. So there's my function. There's my derivative. Derivative of 1/2 x squared equals x. Now they told me that I want my tangent line to be parallel to this line. And we should remember that parallel lines have the same slope. So I need to figure out what the slope of this line is. To do that, I got y by itself. Whatever is in front of x is my slope. So since I want to be parallel, that means I want my derivative, which is x, equal to the slope. So I want x equal to 1/2. So I know my x value is 1/2. It's wanting to know what point. So I got an x value that's 1/2, so it has to be one of these two answers. I need to get the y value that goes with it. Remember, if you want a y value, go back to the original. So I plug 1/2 in here. 1/2 squared is 1/4, and 1/2 times 1/4 gives me 1/8. So my ordered pair is 1/2, 1/8. 19, find the second derivative. So I need the first derivative. Derivative of cotangent is negative cosecant squared. Inside stays the same. Derivative of the inside is 3. So if I rewrite it, I get negative 3 cosecant squared, 3x minus 1. Now, when you go to find the second derivative, you have to realize that this 2 right here is the same thing as having cosecant in parentheses and then squaring it. So that means I need to do chain rule with the 2. So negative 3 stays. I bring the 2 down. My new exponent is 1. The inside stays the same. Then I need the derivative of the inside. So the derivative of cosecant is negative cosecant cotangent. Remember, the inside needs to stay the same. And I'm noticing that I forgot to take the derivative of the inside again. So there should be a 3 right here. So instead of 6 right here, we should have 18. So my answer should be 18 cosecant squared, 3x minus 1 times cotangent of 3x minus 1. I did a common mistake, forgot to take the derivative of the inside. All right, 2 more. 20, we want to determine if f is differentiable at x equals 1. So that means I first need to prove that it's continuous. To prove that it's continuous, we have to look at the right limit and the left limit. So I plug in 1 to both of those. They match. I need my function value. Since there's an equal sign, that means I do have a function value. So I plug in 1. That's there. All 3 of those match, which means I am continuous. Then I need to look at the derivative. So I need to take the derivative of both of these. So derivative of x squared plus 1 is 2x. Derivative of 2x is 2. Then I need to check the limit from both sides. Make sure you're putting the derivative in here. Some of you didn't put anything in here, and some of you put f in there on the quiz. Make sure you're showing the derivative here. So I need to plug 1 into both of those. So I plug 1 into the top, I get 2. I plug 1 in the bottom, I get 2. Since those match, that means f is differentiable at x equals 1. And finally, hoping everybody gets this problem right on the test, because we've been over it many times and there's not much to it. First thing I need to do is plug in to both of these and set them equal. So I plug in 2, so there's 2 squared. I plug in 2, there's 2m plus b. Get one of the variables by itself. In this case, b is the easiest to get by itself, so I get 4 minus 2m is b. Come back in here and take the derivative. Derivative of x squared is 2x. Derivative of mx plus b is just m. Plug in 2 to both of those and set them equal. So I get 2 times 2 equals m. There's nothing to plug into, so it's just going to stay m. That means m equals 4. I come back over here and plug 4 in for m, and that gives me b is negative 4. Notice it wants m minus b, so I want m minus b, so m is 4 minus a negative 4, which is b, and that ends up giving me 8 as my solution. So there are your answers to review for test 2. I hope you'll spend some time looking over it and getting yourself prepared for tomorrow's test.